For 0, it's 1. Again, for minterm 1, it's 1. M2 is here, the top right corner. Then again, 5 is 1. Then 8 is 1. 9 is 1. And 10 is 1. And all other cells will take 0. Okay. So in this example, we can see that rather than grouping the ones into maximum number of cells, there are more chances that we can group zeros in maximum number of cells. Yes or no? Can you make that observation with this example? Can you make that observation with this example?
Yes, ma'am.
Yes. So we can group the zeros together and we can write the expression in easily in product of sum form. Okay. So we'll see how that could be done. Okay. So you can group this entire column, the zeros in the entire column in one group, right? So if it is min term, then these cells should contain 1. Otherwise, you can't group it. So since all the cells here in this column has zeros, now we are going to write this as a sum term rather than a product term. Okay, because I'm grouping zeros. Okay, so if you notice, so in this column C and D remains constant. Okay, so whenever we are writing the sum term, so whenever we have literal value as 1, we will write the literal in its complement form. Okay. So for this grouping, the expression is C dash plus D dash because C and D are taking 1, 1. Okay. For now, you note down this. Okay. So in product of sum simplification, it's grouping the zeros and writing the sum terms. Okay, so while writing the sum terms, whenever the literal takes value 1, you will write it in its complement form. Whenever that literal takes value 0, you will write it in actual form. Okay, so this is one possible grouping. Okay, then coming to this row, okay, row 1, 1 row. So I can group all the 4 zeros here into one group. Okay, and the sum term for this group will be A dash plus B dash. Okay, because A and B, the literals A and B are taking value as 1. So the sum term is A dash plus B dash. Okay. So there are 2 more zeros that are left out, M4 and M6. Okay. But we know M6 and M14 are adjacent to each other. M6 and M12 are adjacent to each other. Then M6, M4 are adjacent and M14 and M12 are adjacent to each other. So you can group these 4 cells together into one group. Okay. So in this group, so the variable B is, the literal B is taking value 1. And along the column, you can see the variable D remaining constant and it's taking value 0. Okay. So we are going to write this as a sum term. So the term we will get is B dash plus D because D is taking 0. So it's B dash plus D. Okay. So this is product of sum simplification. Product of sums simplification. Okay. So when there are chances for grouping zeros and getting a simplified expression, we'll go on like that. Okay. The same thing Now we also want sum of products simplification. So what can be done? So the expression, so if for these groupings, if I group zeros together and if I write the expression in sum of products form, then it is equal to the complement of f. Okay, it is f dash. How many of you can understand this? If I'm following the same groupings and if I'm writing the expression in sum of product forms, the final outcome that I get is f dash. How many of you can follow this? F dash expressed in sum of products form. Yes or no? How many of you cannot follow this? I'll put the other way. Now, are you all there listening or having breakfast right now? Hello, all of you, unmute your mic. Let me do this. Let me check how many of you are following my instructions.
Yes, ma'am.
Yes,
Hello.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am, I couldn't get you. Can you
Yes,
repeat?
ma'am.
Yes, I'll repeat. So, who's asking this doubt?
Vishal Karthik. Roll number
Vishal.
60.
Okay, Vishal, product of sum simplification is clear, or should I explain that also again?
That also is different.
That also. Okay. So sometimes if you, I mean, marking these cells with ones and zeros is clear to you, Vishal?
Yes, ma'am.
Okay. So for the given Boolean function, we will mark all those min terms with 1 and the remaining terms with 0. So that means what? The function, the Boolean function when evaluated give 1 for all these min terms. For if any one of these min terms are true, if any one of these inputs are true, right? Otherwise, the function should give 0 output. That is what is represented in map form, right? So in some cases, if you look at the map, you can see that grouping one may not be possible. Like even in this case, you can see one scattered here and there, and the maximum possibility is you can group two cells together. That's the possible case where you can group two cells together, and that too you will have so many terms included. Okay. So instead of doing that, we will combine the zeros together and we can put this expression in the other form. So in product of sum forms where we will consider only zero, and we already we discussed from the truth table also, by considering zeros we can construct the POS form, product of sums form. Do you remember that? All of you remember that? From the truth table, we will take all those inputs for which the function has to give 0 output. And with that, we were able to construct the POS forms. So same thing is followed here. So when I group the zeros, then I will write the terms in sum form, not in product form.